In this video, I'm going to show you how to perform a goodness of fit test. It is a chi-square test. The program is built onto your calculator. It's called the GOF chi-square test, and it can be done by hand as well using critical values. So I'm going to show you both approaches, and then you can decide which approach you would like to use. So let me begin with an example and explain the process using steps. The following table contains data on the number of customers a shop has on each day of the week. So this is the data right there. On Monday, 95 people shop at the store. On Tuesday, 81, etc. The shop manager makes the following claim: that the number of customers is uniform throughout the week. Test the claim using alpha equals 5%. So what the shop manager is saying, that the number of customers who come and shop at their store each day is the same. That's what uniform means. We need to test whether this claim remains valid or it has changed. In order to do that, you have to set up the null and the alternative hypotheses, and these are the generic statements for HO and H1. In HO, you will always say that the distribution is as claimed in the exercise. So here the distribution of the number of customers is uniform. Your alternative hypothesis will be always the opposite, so that your distribution is not uniform or it has changed. You can put the distribution is not uniform, or you can say the distribution has changed. What is it that is asking us to verify? That we're testing this claim that the number of customers is uniform, so the claim will be in the null hypothesis. The table that you see there is a survey of 1 week on the number of customers who come to the store. I think the total number were surveyed were 700, and we have 7 days of the week. Another way to write the null hypothesis is to put P1 is a proportion for Monday, equal proportion for Tuesday, Thursday, Wednesday, Thursday, Friday, Saturday, Sunday, equals 1/7. Where did I come up with the number 1/7? If the proportions are the same throughout the week, so then the percentages are the same. So take 1 and divide it by 7 days, you get 1/7. The next step is to calculate the test statistic. This is the step that takes a lot of work and time if you do it by hand. The test statistic, it's called chi-square sub-0, and it is the sum of the difference between the observed and the expected value squared, and then we divide by the expected value, and then we add all of them up. So I'm going to show you step by step and how to create this table, and then I'm going to show you how to use a calculator to do it as well. Okay. Usually, if I want you to create critical values on the test, I will provide a blank table, and then you can fill it in. First of all, you put the categories, which are Monday through Sunday. Then you put the observed values. The observed values will always be given to you guys, and these are the frequencies. It is the table that was given to us. On Monday, we noticed 95 customers came to the shop, 81 on Tuesday, 84, and so on and so forth. Now the expected value. The expected value, this is something that you have to calculate yourself. This is how you calculate the expected values. If the claim that made by the shop manager was valid, then the distribution is uniform. If it was uniform, we would have expected the total of all those customers, 700. We would have expected that the number of customers who come to the shop Monday through Sunday would be the same. Since I have 700, if I divide them by 7, I get what? 100 each, and these are the expected values. 100, 100, 100, 100, 100, 100, 100. Now let's say he gives us a different percentages. Let's say they would expect on Monday 10% of the customers, on Tuesday 15%, on Wednesday 20%. How do we calculate the expected values? For Monday, we take 10% of 700. For Tuesday, we take 15% of 700. For Wednesday, we take 20%, and so on and so forth. But because this, in our example, it's uniform, so they are all the same. The next step that you have to do, guys, is subtract E from O. which I did here, 195, 95 minus 100 is negative 5, 81 minus 100 is negative 19, 84 minus 100, and so on and so forth. So these are O minus E. Now O minus E squared. O minus E squared, you square each number, so you shouldn't have any negatives. So I did the square just to save the time here. 5 squared, 19 squared, 16 squared, 20 squared, 17 squared, 10 squared, and 7 squared. Then I did O minus E squared divided by E, which is 100. So I put 25 over 100, this number here, divided by the result from this cell here. 361 over 100 all the way to 49 over 100. Your test statistic will be the sum of all the results in the last column. So I just add them up and I got 14.80. Now for your information, this is a right tail test. The goodness of fit is a right tail test. So now we're gonna find the critical value and make a decision whether to reject HO or fail to reject HO. So let me show you how to find the critical value here. In order to find the critical value, you need two arguments. First of all, the significance level, which is 5%, and then you need the degrees of freedom. The degrees of freedom for the goodness of fit test is the number of categories minus 1. Number of categories in our exercises, the days of the week, we have 7 days, minus 1 will be 6. So we are looking for 0.05 and 6. So let me show you here. If I show you my pen here at 0.05 and then go down to 6, which is, as you can see, it's 12.592. So this is my critical value. Now I'm going to go back to the exercise and write down the critical value, which is 12.592. Okay, the critical value is 12.592, but my test statistic from the previous step was 14.80. Where's 14.80, guys? It's going to be on the right? Because it's bigger than 12.592. So it's going to be somewhere here. And this is a right tail test. So as you can see, it's in the rejection region. So what's my decision is going to be here? Reject what? HO. And what is your conclusion here? Since the claim that says the distribution is uniform and we rejected, HO, so we reject the claim. So there is enough evidence to reject the claim that the distribution of the number of customers throughout the days of the week is uniform, meaning it's not uniform since we rejected HO. So I'm gonna type this one, and that concludes the question using the critical values. Now I'm gonna show you how to do this question using the calculator. So as you can see, there is enough evidence at the 0.05 level of significance to reject the claim the distribution of the number of customers at the shop throughout the week is uniform, meaning that we can conclude that the distribution is not uniform. So that means we don't get the same number of customers each day. Now using the calculator to solve this exercise. First of all, you have to state HO and H1 as we did by hand. The calculator doesn't do that for us. But the calculator can calculate the test statistic, chi-square sub 0, and the p-value. No critical values when you use the calculator. How do you calculate the test statistic using the calculator? You're going to like that. It's very easy. You don't have to do the table that we did there. Let me just get rid of this. Cancel. Sorry about that. Okay, we go to stat, edit, enter. We enter the observed values in L1, which I did already to save time, and the expected value. Usually you would have to enter the expected value in L2. Then you quit. Then you go to stat. You go to tests. Scroll up. And here is the test, guys. It's chi-square goodness of fit. test. Press enter. Observed by default is in L1, L2, which I have them in L1, L2. So let me, now degrees of freedom, I said it's number of categories minus 1. I have 7 days, minus 1 will be what? 6. And now watch how easy it is. Calculate. Test statistic is 14.8. And the p-value, do you notice the p-value, guys? It's 0.02187, which is less than 5%, so we reject HO. Same conclusion as we got when we used the critical values. So we reject HO, and the claim happened to be an HO, so we rejected the claim. And we conclude that distribution is not uniform. So if you use the calculator, use the p-value, no need to do critical values. You just write down the p-value and make the decision using the p-value. If p-value is less than alpha, we reject HO. If p-value is more than alpha, we fail to reject HO. So this is how we perform a goodness of fit test. I hope that helped. Okay, so